This is example 4-1, flow out of a gutter. So we are asked to find out what the volumetric discharge is coming out of this trough or gutter, whatever you want to call it, half pipe. And so we know that Q is equal to A times the area times the velocity. Velocity is given to us, so let's start figuring out our area. So we have a half circle like this, but we only have it partially filled like that. So now we need to figure out what that is, and I think what we'll do is we will divide this into two slices. All right, this will be a slice, alpha, same alpha here. That would give us this kind of area, and then we're left with this triangle to subtract out of it. So we do the semicircle, and then we subtract those two parts out of it. Now to calculate this, we need to know, or we already know, that this height here, this area is A, and we'll call this top part here B. And we'll draw this triangle separately. Right, so it'll be this triangle right here. This would be A, in our case, 0.1 meter. We know this here is R, 0.4 meter. We have an angle here, which we call alpha, and then we'll have B up here. So let's figure all these things out. So if we want to find out B, we can use Pythagoras' theorem. We'd have R squared is equal to A squared plus B squared. That means B is equal to A squared, R squared, minus A squared. All right, in our case, that is square root of 0.4 meters squared minus 0.1 meter squared, and then we take the square root of that, and that gives us 0.38729 meters. So that would be the length B up here. We can also find out what the angle is. So we can say alpha. So if we take A is what we have, and we have R, right? So we'd have the opposite leg, right? So we'd have sine to the minus 1 of A over R equal to sine to the minus 1 of 0.1 meter divided by 0.4 meters. The meters cancel, and we get 14.47751 degrees. All right, so now we have all those little details. We can go in and figure out what the actual area is, right? The area, again, the idea is that we'll take this entire semicircle, and then we cut out this top piece here by using two slices and then two triangles. So we'd have A is equal to the half circle, so 1/2 times pi r squared, and then we need to cut those two pieces out. So we'll cut out the two slices, so that would be alpha divided by 360 to get that one section times pi r squared, and then minus our triangles, so 1/2 times A times B. All right, what does that give us? That gives us 1/2. Let's write that in the same way as over here, so that would be 180 degrees over 360 degrees, pi r squared, minus 2 times alpha over 360 degrees, pi r squared. Now you can see why I rewrote the first term, and then minus AB. So that's then 180 degrees minus 2 alpha divided by 360 degrees. Pi r squared minus A times B is equal to 180 degrees minus 2 times what we calculated up there, 14.4775 degrees, divided by 360 degrees times pi times 0.4 meters squared minus A times B. What is A and B? A is 0.1 and B is what we calculated. It would be 0.1 meters times what we have up here, 0.387298 meters. Let's look that we have square meters on both sides. That all works. So if we plug this in, we get 0.172169 meter squared. All right, so this is the area that will have the water flowing through. Now, if we do kind of a cross section through our pipe there, right? Then we have at an angle, the outflow is horizontal, and everything is at the angle. We know this is 30 degrees. We know that our water is coming out at the same as the pipe, but the area, right, the vector of the area is perpendicular to the cross section, so it's at a different angle. All right, so that means we have 30 degrees here as well, because that's 30, so that has to be 30, which means if we want to calculate Q, we'll have to take that into account, right? Remember that Q really are V and A, both are vectors, so we can just do the vector product. We can say that be V times A times cosine 30 degrees, or 3.6 meters per second times 0.172169 meters squared. That would be our A, and then times cosine 30. And that gives us 0.53677 cubic meters per second. Right, we have the second here, the meters and the meter squared. If we round this off, we get 0.537 cubic meters per second. Right, that will be our volumetric discharge across that surface.